and you'll be able to review the audio plus whatever video that we write on this tablet.
All right.
And the way I usually do this is I have the student voice the problem, and I write it, and then we both solve it. So
Okay.
what are we doing today? First day we did algebra. Last time we did trig. What are we doing today?
A little more trig.
Okay.
Am I allowed to write on the thing, or?
Well, no, but
No.
you actually, no, without a drawing tablet on your end. I actually have the ability to toggle back and forth and make you the presenter so that we would both be looking at your screen.
Well, I actually have a drawing tablet that my dad hooked up.
Okay, well, that's interesting, but I've tried it that way, where the student has a drawing tablet and I have a drawing tablet, and it's so hard to toggle back and forth that it ends up being better if we just work with one drawing tablet.
Okay.
That usually is mine, and what happens is you voice the problem, and I will write it out.
Okay. So, I guess I'll tell you the first problem then.
Okay.
The first couple are pretty easy. One says y equals sine of 4x, and then it asks for the amplitude and the period.
Okay, what's the amplitude?
Doesn't give you that, so.
No, I'm saying, what is the amplitude of this function?
Well,
It would be the coefficient in front. What is that? It's 1 in this case.
1. That's, yeah, it's 1.
What is b?
Hang on. I'm trying to review some of the notes.
No, that's fine. That's fine.
Yeah. Well, okay, so the thing is, I lost my backpack a couple days ago, so the notes you gave me are gone.
Okay. Well, that's okay. We'll review it from
All right.
In this case, let me write out the general formula of a sinusoid function. And I'm still not sure if you've had all of this, but it doesn't matter. You'll be able to understand it.
Okay.
You may have only had problems that involve a and b. For instance, this function right here only has an a and a b. It does not have c, which is the phase shift, and it does not have a d, which is the vertical shift. So this is, however, the general formula of a sinusoid function. And at some point, you'll get all 4 of these letters. For now, let's just work with the degree of difficulty that you have, which is determining A and which is determining B. What would B be in this case?
Is B4?
Yeah. Now, here's the next thing you have to remember. The period of the sinusoid function is equal to 2 pi divided by B.
That's right.
Which, this is what you want to memorize. But it also means b is equal to 2 pi over the period. In other words, had they given us a graph where you could figure out what the period was, you'd be able to figure out what b. In this case, we're going from the function to a graph. So the only thing you need to know is this part. So what's the period of this particular function?
2 pi over 4.
Which is reduce it to pi over 2. Okay. Now, if we want to know what that graph looks like, well, the amplitude is 1, so it goes up to 1 and it goes down to -1. We know the sine function starts at 0, 0. It ends normally at 2 pi. In this case, where does it end?
Would it end at... Ouch. Sorry, I just did something that messed up my thing.
What's the period?
The period is 2 or pi over 2.
That's where it ends.
That's where it ends.
Okay. In other words, the period is the spot between where it starts and when it starts again. Okay? So, now my next step is to quarter that up. If that's pi over 2, what is that?
That is pi.
Pi over
Over
4. Half of pi over 2. And this is half of pi over 4. So what is this?
Pi over 8.
Now notice that this is pi over 8. This is 2 pi over 8. This is 4 pi over 8. So what's this point going to be?
3 pi over 8?
Yeah. That's all I need to draw my graph. In other words, there's no phase shift, there's no vertical shift. So I know at the first quarter point, it's going to hit its maximum. At the second quarter point, it's going to come back through the x-axis. At the third quarter point, it's going to hit its minimum. And at the fourth quarter point, it's going to come back to where it started from. So the way I draw this, make sure I go through all 4 points. There's my sine curve. It's got the right amplitude. It's got the right period. There's no phase shift, which would be a left or right shift. And there's no vertical shift, which would be up or down.
Okay.
Okay. What's the next one?
It's kind of the same type of problem.
Okay,
Only
go ahead.
it's minus y equals minus 4 cosine 5x.
Okay. What's A?
A is negative 4.
What's B?
B would be 5.
What's the period? In other words, we can't draw the graph until we know the period.
So it would be 2 pi over 5.
Okay.
Okay.
In red, I am going to draw one period of cosine of x.
Okay.
Starts at its top. Goes down through the 0 there. Goes down to the bottom at minus 1. Comes back up through the 0 at 3 pi over 2. And finishes where it started from. Notice that if I drew another period of this thing, we'd be just redrawing the same graph. All right, in blue, I'm going to draw this graph. Well, first of all, let's examine the amplitude. What does that mean, minus 4?
It's going to have a vertical stretch.
Okay, so I'm going to go up to 4 and I'm going to go down to minus 4.
Okay.
But what's the minus sign mean?
Oh, that it's reflection.
Exactly. So it doesn't start here. Where does it start?
Where does it start on what? I'm sorry, I missed that.
Where does it start on our curve? In other words, on this curve right here, a normal cosine curve, in other words, this thing that I've labeled.
Oh, it starts on 1. Okay, so then it would start on
cosine x. We want y equal minus 4 cosine of 5x. So I need to figure out where it starts.
minus 4.
Good. So I'll put an x right through there. Now, its period is 2 pi over 5.
Okay.
Well, if I try to draw that on this graph, it's going to be somewhere about here. And I'm not really going to be able to show it properly. So let's expand the axis. I'm going to take away this cosine curve. And I'm going to make this 2 pi over 5, just so you can see. In other words, the very first thing to do is to draw your starting point and your ending point. Well, I know my starting point's there. I know my ending point is there. What are the quarter points? What's this halfway point here?
Pi over 5.
Okay. What's this quarter point?
I'm sure there's a better way to.
Just divide it
Maybe
in half.
pi over 10.
Yeah, there you go.
Pi over 10.
Okay, now notice that this is pi over 10. This is 2 pi over 10. This is 4 pi over 10. What's this one?
3 pi over 10.
That's the way to do these. Okay? All right, so I got my 4 quarter points. I got my beginning point. I got my ending point. So let's draw it in blue. I know I have to go through this point. And then the next point is the x-axis. So the first quarter point, you go through the x-axis. The next quarter point is where? Where is this function at pi over 5?
It's at 4.
So here's my next quarter point. Where's my next quarter point?
It's going to be at the x-axis on 3 pi over 10.
And the final quarter point?
Minus 4.
Now connect the dots. Connect the dots and make it look like a cosine curve that's been reflected about the x-axis. Okay? So I think you can begin to see that the most important thing with doing these is knowing what the original curve looks like, what sine of x looks like, and what cosine of x looks like. And then all we're doing is adjusting those curves. We're either adjusting the amplitude or we're adjusting the period.
Okay.
Okay? And actually, those are the two toughest things. In other words, adjusting the phase shift and the vertical shift does not change the shape of the graph. Because all it does is moves it right or left or up and down. In other words, if we had a C and a D, let me draw an example. If I had this function right here, that has an A, a B, a C, and a D, and a negative sign. In other words, a flip over the x-axis. So there's 5 things going on with the original function. And you just have to do them one at a time. If you get to that level. I'm not sure that you're... So far, I don't think you've given me a C or a D in the problems you've given me. What do you got next? Now, it may be something we want to do at this session, but at some point in time, you're going to want to send me a picture. In other words, they're going to give you a graph, and they're going to say, come up with the equation. In other words, they'll give you a graph like that, and they'll label that 4 pi. And they'll label that 1, or let's say 2, and they'll label this minus 2. In other words, if I gave you this graph, you should be able to come up with the function. Right. Let's see if you can. What's A?
Would it be A is 2?
What is the period? Because that's the only thing we can read from the graph.
4 pi.
What is B, therefore?
That would be 2 pi times 4 pi, which is 8 pi.
B is 2 pi divided by the period.
Oh, okay. So then would it be 1/2?
Yeah, just 1/2. not 1/2 pi. Notice the pi's cancel.
Yeah.
Okay, so what's the equation of this thing?
Y equals 2 sine 1/2 x.
That's the way you go from a graph to a function.
Okay.
Okay, and you're going to have to go both ways. You're going to have to be able to graph that, and you're going to have to be able to write the function for that graph. Well, the problems where you have to write the function from the graph are going to be difficult to verbalize for you. Do you have any like that today?
Yeah, I do.
Can you take a picture with your camera?
Okay, do you want me to send it to you through text?
Send it to my email. I will write that on the screen right now. And once you do it one time, it'll be far easier to do it the next time. Because your camera or your phone will remember. Because all you'll have to do is put in like the first 2 letters of my name, and it will remember where you sent a previous email. Do you have an iPhone or an Android phone?
I have an iPhone.
Okay. There is a setting on the camera that you have to make. Yeah, we'll see what kind of picture I get. But I've had a lot of iPhone users, they don't have the setting correct, and I get a blurry image. We'll take a look here. Have you done this very much, taken pictures and sent them up to an email?
Not really.
Okay. Well, I kind of wanted to do it this first session so you'd know how to do it. It's not terribly often that you need to do it. Most of the time, it works really well for you to verbalize problems. And in fact, that's very helpful for you to get some experience in verbalizing problems, because it's something you don't get to do in class very often.
Yeah.
You know, how often do you stand up in class and verbalize a problem? Probably never. So it's actually pretty good for you to verbalize problems, but some problems just can't be verbalized very well, like graphs.
So I'm typing in your email right now.
Okay, go ahead. Most important thing about taking a picture is lighting and holding the phone steady. If you hold the phone steady and you have reasonably good lighting, I'll be able to bring up a crystal clear image. But if either one of those are off, it's not so easy to read it when I bring it up on my screen.
Okay, so I think I just sent it.
Okay. Let me pull up my inbox. Usually if there's a picture attached or something, it takes maybe 30 seconds to a minute to send. While I'm waiting for it, let me let my dog out of my room. You put the 1949 on there?
Yeah, I think I did. Let's see.
Yep, you did. In other words, my smartphone received it before my computer did. I don't have it, unless is it Alexa? I've got, yeah, this is you.
That's weird.
That it is identified as Alexa?
That's one of my friend's Gmail accounts, so
That
I
is
don't know. I think I'm just signed into...
That is weird.
I think I'm just signed into hers.
Okay, that's okay. As long as I get this document, now you'll see what I'm talking about. Okay. Yeah, I can see that problems 4 through 9 are ones where they want you to graph these, basically. I mean, they want the amplitude and the period, but that's part of graphing it. And then 10, 11, the rest of them, they show you the graph, and they want you to figure out the amplitude and period. So let's see. We didn't do number 6 yet.
No.
Let's talk about number 6. What's the consequence? What's the amplitude?
A is 2.
What's B?
Would it be -4?
Yeah, but there's something about trig. In other words, here we have the negative sign inside the parentheses. Okay? What that typically means for a function is that it's going to be reflected about the y-axis. But more importantly, let's talk about these properties. Remember odd and even functions?
Mm-hmm.
Well, sine is odd, cosine is even. An odd function, the sine of -x is the same thing as minus sine of x. In an even function, the cosine of -x is the same thing as cosine of x. That's the difference. You with me?
Yeah, so then it would just be reflection?
About the x-axis. In other words, I'm going to take this negative sign, and the first thing I'm going to do is move it in front of everything. So number 6 is the same as, and that's my first step. Because I know how to handle, at this point, you know how to handle that negative sign. It's a reflection about the x-axis. Well, with sine and cosine, with sine, a reflection about the x-axis is the same as a reflection about the y-axis. Notice if I draw the sine function, hold on. If I draw the sine function and reflect it about the x-axis, I get this. If I reflect it about the y-axis, I get the same thing. Okay? And that's just a property of the sine function. So that's why we can do this first step, which is to take that negative sign, move it in front of the function, and now we know that we're really plotting this function here. So they didn't even ask about that. I'm just explaining that as to how to treat the negative signs. I'm not quite sure why the only 2 questions they ask here are for amplitude and period, because by throwing these negative signs in, they throw a third question in, which is it a reflection? So the amplitude here is 2, B is 4, what's the period?
2 pi over 4, which is about
pi over 2. And what that means is we've got to draw the entire curve between 0 and pi over 2. Which means we quarter it, and draw our points. In this case, it goes up to 2 and down to -2, and its first quarter point is right there.
Okay.
Second quarter point is where? No, we're dealing with, okay, I made a mistake here. I drew the quarter point for cosine. This is sine. Where's the first quarter point go?
At 0.
Thank you for correcting my error. Where's the next quarter point go?
If it's a reflection, would it be to -2?
The third one?
At 0.
Fourth one?
At 2.
Fifth one?
At 0.
Connect the dots. There's the curve. You actually look like you may not have your picture settings set on optimal.
Oh.
I can certainly read this, so I'm not complaining. But just if you want to send the highest quality photographs to people, you probably should change your setting, because this is not up to an iPhone. iPhones have really good resolution. You probably have a camera that's at least 8 megapixels. It should send out crystal clear images. This is readable, but not crystal clear. Okay, so what's the amplitude of this function? Number 7, what's the period?
It's 2 over 3x divided by pi.
Hold on. Let's write it out. Just a second. My biggest problem is making sure I can get my windows in the screen. So the period is 2 pi over what?
B.
Which is?
2 over 3x.
Just 2 over 3. B is only the coefficient.
Right.
Now simplify that.
Okay. So that'd be
Flip the denominator and multiply.
That would be 6 halves pi, so then 3 pi?
Yep. So that's the period for number 7.
Okay.
Okay. Number 8, what's the amplitude?
-4.
Well, technically just 4.
Okay.
But the minus sign is a different effect. That means it's also a reflection over the x-axis. So, I don't know. They probably do want -4. Actually, I believe the amplitude is actually defined as the absolute value of this number. So, I would say here the answer is 4. I'm not 100% sure about that, but every book I've ever read, the amplitude is the absolute value of this coefficient. And then the negative sign means it's just a reflection over the x-axis. What's the period? Number
8. 2 pi over 5.
That's it.
So.
Number 9. Amplitude is 3. Now, let's look at number 9 for a second. It's the first one we've seen like this. Well, how can I handle that negative sign inside the parentheses?
Is it just -2x? Or is it just...
Remember that cosine is an even function.
Oh, right. So
means
then...
cosine of minus x equals cosine of x.
Okay.
So what would the effect... How do I handle that negative sign?
You just ignore it.
Exactly. Let's rewrite it. It's the same as this. Okay. Tangent, incidentally, is odd. So tangent's the same as sine. And then, of course, all 3 reciprocal functions are the same as their reciprocal. You know what I'm saying? In other words, sine is odd, so is cosecant. Cosine is even, so is secant is even. Tangent is odd, so therefore cotangent is odd. So now, to plot this, A is 3, what's the period?
3 pi.
What's B?
2.
Remember, the period is 2 pi over B.
Oh, or so then it's just pi.
Right.
I was thinking of the...
What that means is that when we have a number in front of the x, it acts as a vertical scrunch. If we have a number in front of the trig function, it acts as a vertical stretch. What I mean by that is because our period is now pi, I've got to complete the function by pi, not 2 pi. So I know that if I was just drawing a period, it would go like that. Notice that the 2 scrunches the curve horizontally. Because a typical curve, you'd have to draw it like that. You'd go all the way to 2 pi. So the effect of this 2, a number greater than 1, is a horizontal scrunch. The effect of this 3, a number greater than 1, is a vertical stretch. They're opposite. They have opposite effects. If I put a 1/2 in front of that, that is a vertical scrunch. And if I put a 1/3 in front of this, that is a horizontal stretch. Okay? So just know that they do opposite things, depending on whether they're greater than or less than 1. All right, let's look at some of these curves. Let's look at number 10. What's the period on 10? Well, what's the amplitude on 10? The easy part.
That's 3.
What's the period?
2 pi?
Find a starting place and find where the next starting place is.
Oh, okay.
The difference, there's one starting spot. You can go peak to peak. The problem with going peak to peak in this problem is they haven't labeled the x-axis very well. Right?
Mm-hmm.
Even if I were to go valley to valley, they haven't labeled the x-axis very well. But what they have labeled is this point, which you know to be 0, and the next starting point is right there.
Maybe 1 1/4 pi?
Well, only because they've put their pi offset from where it's supposed to be. In other words, you're dealing with a very inaccurate graph here. If this is 2 pi, what's this? Pi. That's where pi is. This label that they put right here should have been put right on top of this point right there. Okay? So it's not always easy to read the horizontal axis on these problems. But that's certainly where pi has to be if this is 2 pi. They've labeled 2 pi properly. Well, the halfway point is... Yeah, I have 2 full periods here. Okay, there's 1. Let me draw it with my cursor. There's 1 period. There's 2 periods. Since this goes to 2 pi, this spot, by definition, has to be pi, even though their label is way over here. I hate that when they confuse the issue. But our period here is pi. So what's the equation? Hold on a moment. Let me move this. We said that A was 3, and that the period is pi, therefore B is what?
Pi over 2 pi?
B is always 2 pi over the period?
Or 2 pi over pi.
Okay, so what's B?
2.
What's the equation?
Y equals 3 sine...
And this is sine because we start there. In other words, we're starting at 0 and going up. So it's positive sine.
2x.
That's the equation. About number 11, what is the period? Excuse me, I'm sorry, what is the amplitude?
4?
What's the period?
2 pi?
So what is B?
So 2 pi over 2 pi, so that's
No,
1.
yes. Sorry. Okay. So what is the function? What are we looking at? Are we looking at a sine, a cosine, a negative sine,
Cosine.
a negative cosine? Okay, so it's what?
4 cosine x.
Very good.
I'm probably going to need to take a better picture.
No, I can see enough here.
Okay.
We only need to see the amplitude. What on number 12? What's the amplitude?
2.
What is the period?
It looks like 4 pi.
Which means B is
2 pi over 4 pi.
which is
Half pi, or 1/2.
1/2. Makes a difference. Sometimes you're going to have a pi with B, sometimes you're not. So, what's the equation?
Y equals 2 sine 1/2 x.
13. I think this is 13. Yeah. 13. Hold on. What is the amplitude? What is A?
5.
What is the period?
2 pi.
What is B?
That's 2 pi over 2 pi, so 1.
And what are we looking at? We looking at sine, negative sine, cosine, or negative cosine?
A negative cosine.
So what's the equation?
Y equals negative 5 cosine. X.
Very good. Now, there's some, I don't have to worry about that yet. Okay, so we've done those 4 problems. Do you have more?
Yeah, I do.
Are they ones that you can verbalize, or are they graphs that I need to see a picture of? In other words,
Some of them
if they're just functions, you can verbalize the function, and we can draw the graph on my screen.
Yeah, they're functions that ask you to draw the graph on the graph that they've given you.
That's fine. Go ahead and give me the function, and we'll do it. We'll do it this way.
Y equals 3 sine x. And then it wants the amplitude and period also.
What's the amplitude of that?
3.
What's the period?
B would be...
Remember the natural period of sine and cosine, always.
So then it's 2 pi.
Right. So I've got to finish my curve by that point. Now this is just a standard sine function, except for what? It goes up to what and down to what?
3 and negative 3.
What do you got next?
Let's see if I can find it. I'll try and find something. Okay, so there's one that says y equals 3 cosine 1/2 x.
Okay. It sounds to me like everything today is going to be with just an A and a B. Is that correct? In other words,
Yeah.
you don't have any problems on there that have a C and a D? Because if you do, we only have 15 minutes left. I want to make sure we cover them and we don't ignore them. I feel pretty good that you understand this perfectly. Do you feel pretty good about that?
Yeah, I think so also.
With just A and B, you seem to understand it.
Yeah, this was just a review of the last chapter, so I think it's probably just going to be A and B.
Okay. C and D, even though it's easier because there's no shape adjustment, it's just moving it horizontally or vertical, C does present a problem. And let me tell you what it is. In this case, C is the phase shift, which means if I had a sine curve that was phase shifted by pi over 2 to the right, here's how I would draw it. I would move pi over 2 to the right, start my curve there, figure out that my period was 2 pi, so I would end it at 5 pi over 2, and I would draw my curve. That's what a phase shift does. That's with a C of 1/2 pi.
You could also do it as a cosine equation, right?
Almost. You would do it as a negative cosine equation. In other words, if I extend this thing, looks like the negative cosine curve, and that's exactly what it is. So a phase shift of pi over 2 to the right is the same as changing sine to cosine. And no matter which function you use, you can always throw in a phase shift and use the other function if you want. And the general rule of thumb is you use cosine or sine, whichever one results in a less phase shift. In other words, you're right. I wouldn't say x minus pi over 2. I would say negative cosine of b. However, here's what I'm trying to point out, is that some school systems in Colorado stick the b inside the parentheses. Or, even if it's not a school system in Colorado, if that b is inside the parentheses, it's a different general format. Those are not the same. Doesn't change the period. B is the same either way. But what it does do is change the phase shift. When the b is outside the parentheses, like that, your phase shift is C. When b is inside the parentheses, your phase shift is C divided by b.
Okay.
So it matters. And regardless of whether your system puts it inside or out, I don't even know yet, because when you're only dealing with period, it doesn't matter whether it's inside or out. But if you have a phase shift, then it makes a great deal of difference. In other words, if I were to give you these two functions, or this, these are the same functions. So all I did to get the second function was, if I take this function and factor a 2 out, what do I get?
You get x minus pi over 4.
Same thing as this one here. So it makes a difference whether the coefficient is inside the parentheses or outside. It doesn't make a difference to the period, but it makes a big difference to the phase shift. Okay? So C is only the phase shift if the coefficient is outside the parentheses. And I don't really know. Once you get into this, I'm not sure which one they're going to give you. They're liable to give you a combination of them. You're liable to see this. You're also maybe liable to see this. So the only thing that's necessary is that you know how to handle the difference. Essentially, you want to get that coefficient outside the parentheses. So if they give it to you inside the parentheses, factor it out. Okay? And then D is really easy. There's no difficulties with D at all. For D, it does not matter whether B is inside the parentheses or not. D is strictly a vertical shift. In other words, if I said y equals sine of x plus 3, instead of drawing this thing about the x-axis, I'm going to move up 3 units, draw a new line of symmetry, horizontal, and I'm going to graph it like this. I'm going to go up to 4 and down to 2. Like that. Okay?
All right.
So just an advance on C and D, which I suspect you will cover. I'm not positive. It's possible they may not do a C and a D at this level of math. What else do you have that you can verbalize? You've got about 10 minutes. In either this or algebra, I mean, you don't have to stick with this subject. Stick with whatever questions you feel like you need help on.
Let's see. I have a word problem that I could probably do on my own.
No, those are hard. Go ahead and give it to me. We'll talk about it.
It just says find an equation for a cosine function that has an amplitude of 3 over 5 and a period of 3 over 2 pi.
All right. So if the period is 3 over 2 pi, we need what?
B?
Which is?
That would be...
it's always 2 pi over the other thing.
2 pi over...
In other words, B is 2 pi over the period, and the period is 2 pi over B.
Okay.
Okay? So it's 2 pi over 3 over 2 pi. Flip and multiply, what do you get?
That would be 6 pi? Or 4 pi?
4 pi squared over 3.
Okay.
In other words, the algebra involved with that right there is just flip the denominator and multiply. So you end up with 2 pi times 2 pi over 3. Well, that's 4 pi squared over 3. So, what's the equation of this thing?
So then it's going to be... Wait, hang on. It was a cosine equation.
Right.
So then it would be y equals 3 over 5 cosine.
Correct.
And then 4 pi squared over 3x.
And that's the correct way to write it. It's not to turn it into a decimal number. In other words, that's the most accurate way to write that number, because pi is irrational.
Yeah.
The moment we try to convert that to a decimal number, we're going to be rounding it off. And we don't want any round off error at all.
Yeah, or just write infinite numbers.
Yeah, in other words, whenever you're expressing stuff like square root of 2, square root of 3, pi, e, it's always best to express them this way, because that's the most accurate description of that point on the number line. All right, what else you got?
There's another word problem, and then after that I'm not sure.
Okay.
Find an equation for a sine function that has amplitude of 5 and a period of 3 pi.
All right. These are word problems, but they're not word problems in the sense that they're hard to do. In other words, here's a difficult word problem. You're breathing. Your lungs hold 5 gallons of air when you've taken a breath. They hold 1 gallon of air when you've expended a breath. You breathe every 6 seconds. What's the equation of that model? That's a typical word problem.
Yeah.
They won't probably give you those until they've covered C and D. In other words, you need the phase shift and the vertical shift to handle those kind of word problems. These kind of word problems, it's pretty straightforward. They said this was sine.
Mm-hmm.
Okay.
So
what's
then,
B?
2 pi over 3 pi.
Which is?
2 over 3?
So the equation is
5 sine 2 over 3 pi, or x.
x. Big difference. Now, notice that as long as we don't have a c, it doesn't matter. There's no parentheses used here. In other words, I don't have parentheses around that. I don't need them. The moment I introduce a c, then it's very critical whether you have parentheses or not. Okay? What else?
And then there's one last word problem, and then that's just about the end of the worksheet.
Okay.
Find an equation for a sine function that has amplitude of 4 and a period of pi.
Pi?
Yep.
What's b?
B is 2 pi over pi, so just 2.
So the function is?
Y equals 4 sine 2x.
There you go. I like the way they're teaching you this. In other words, they're spending a lot of time getting you to work with A and B before introducing you to C and D. Whereas a lot of students, they give you all 4 letters at first, and then it's just so different that it's hard to absorb it all. But
yeah,
these two numbers, A and B, which typically are harder to understand because they do change the shape of the curve. They either vertically stretch it or scrunch it, and they horizontally stretch it or scrunch it. But they do it in opposite manners. But I do believe you've got this stuff down pat. You agree?
Yeah, I think so.
Yeah. You know what the negative sign, the biggest thing, let's just review one thing. The biggest thing that you need to know for your current material is the answer to these two things. In fact, let's add tangent to the list. What's sine of negative x equal to?
Sine of negative 1 plus x.
Because it's an odd function, what is it equal to?
Just negative x?
Negative sine x.
Oh, negative sine x. Okay.
Because cosine is even, what is cosine of negative x equal to?
Cosine x.
And because tangent is also odd, just like sine, tangent of negative x is equal to?
Negative tangent x.
Okay. And the only other thing to remember is that the natural period of tangent is pi, not 2 pi. And that matters because if I said graph this, well, here the b is equal to pi over the period. And the period is equal to pi over b. So the moment you start talking about tangent, you're talking about a different period. If I graph the have you dealt with tangent graphs at all?
Not a whole lot.
Okay,
No.
well this is what the tangent graph looks like. And you'll notice that it repeats this goes from minus pi over 2 to pi over 2. It repeats every pi instead of every 2 pi. So the natural period of tangent is only pi, as opposed to sine and cosine, which is 2 pi. And that changes these two equations for tangent. Not to confuse you, I hope that didn't, but you'll probably get to this part next week, where they bring in tangent, and they probably are going to bring in a phase shift and a vertical shift also.
All right.
But for now, that's pretty good. I do believe you're getting this stuff. Now, what's the best email? In other words, I'm recording this. Let me go ahead and stop the